Welcome to 2.3, real zeros of a polynomial function. The hunt for zeros is on now, and that's much of what we're going to be doing for the next couple sections. And here we have the division algorithm, and I invite you to read through this, but we've got lots of words that have to do with when we divide numbers. We have dividend, divisor, quotient, remainder, and I want to try to make sense with this for you out of just doing old school division right here. So we're going to take 5 into 37, and of course 5 goes into 37 7 times, and we'd get 35, and we subtract that and we get 2, and we have a remainder of 2. Now let's put this all together. This 37 is called the dividend. So this would be 37 equals what we divided by is the 5, that the divisor is 5, times the quotient we get is 7, plus the remainder we get is 2. Old school, we would have said, oh, remainder 2. We also know we could write that as 7 plus 2/5. So this is just the division algorithm, just shown without working with polynomials right here. So we'll come back, we'll talk about that again. And then they discuss synthetic division, which really, I believe you've been exposed, most of you have been exposed to synthetic division before. It's actually a pretty slick and cool process and does a lot for us, but it will make a lot more sense when you see an example of it. We got the factor theorem that says a polynomial f of x has a factor x minus k, for instance like x minus 3, if and only if f of k equals 0. So if x minus 3 is a factor of a polynomial, and let's say the polynomial factors into these three factors, if f of k, if f of 3 equals 0, when I put 3 in, that's my myvox. If I put 3 into this function, of course we're going to end up equaling 0 because it makes that term 0. So again, another one that might make a lot of sense to you soon. And using the remainder theorem in synthetic division says if we go through whatever this synthetic division process is, which will make sense when you see it, we end up with the remainder here. The remainder r gives the value of f at x equals k. That is, if k is 7 and I run 7 through this process, the remainder I get here is what f of 7 is. And that's all it's saying. And let's see here. If r equals 0, if the remainder is 0, then k, if the remainder is 0, then x minus k is a factor of f of x, and if r equals 0, then k0 is the x-intercept. These are really just synonymous, and again, I think they'll make a lot of sense when we go through that process. And then the rational zero test, we're going to actually come back and talk about that as we get to those problems a little bit later in this section. So, quick disclaimer on this. This page, it's going to test your writing small abilities here. So you might want to get a nice sharp pencil and prepare to write a little bit smaller on some of these problems, as you're about to see. So I'm going to try to keep it legible, but I'm going to zoom in here because I'm going to keep my writing small to fit these in. I probably could have spaced this out a little bit better. So we're going to use long division to divide and use the result to factor. So I'm going to divide into 5x squared minus 17x minus 12. I'm going to divide into x minus 4. Just old school long division. And so what do I do here? I ask myself, what do I have to multiply by x to turn it into 5x squared? Well, that's 5x. And I put that 5x, the plain old x to the first, over the plain old x to the first here. So when I do that, when I distribute this to the x minus 4, I get 5x squared, 5x times minus 4 minus 20x. And then we know we're going to put our line here and we're going to subtract. And I always, when I put this, we get 5x squared minus 20x. When I put this line here, I say but, so it's 5x squared minus 20x, but we are subtracting. So those signs change. Easy to forget that. I always say but we are subtracting, as you're going to see. So 5x squared minus 5x squared cancels it better. Negative 17x plus 20x, 3x minus 12. And then I ask, what do I have to multiply x by to get 3x? Well, that's plus 3, and that gives me 3x minus 12. Watch this. But we are subtracting, and we found out that, yes, in fact, x minus 4 divides this evenly, no remainder. So use long division to divide and use the result to factor. Well, the factors of this then must just, be x minus 4 and 5x plus 3. So just based on the directions here, I expect these to divide these out evenly. Okay, a little bit more to this one, and we're going to need a little bit more space on here. Did pretty well there, had more space than I needed, but you're going to find out we're going to get pressed on this. So here we go. I've got 2x cubed minus 3x squared minus 50x plus 75 is being divided by 2x minus 3. 2x times what is 2x cubed? X squared. So I'm going to put that above the x squared. And again, you don't have to put the parentheses here, but I'm just emphasizing that we're distributing this x squared to those two terms. We get 2x cubed, and we get minus 3x squared. And here we go, but we are subtracting, opposite, opposite. So this is 0, this is 0, and that's kind of a bonus 0 right there. So it's actually going to allow us, I mean, we're going to have some space here, that helps. So we get 0, we get minus 50x, and since 2x goes into this, I get to bring down this 75 as well, plus 75. 2x times what is minus 50x? That's minus plain old 25. See, I don't end up with an x term here. So that would be distribute minus 50x minus times minus plus 75, but we are subtracting, opposite, opposite, and we end up with 0. So our factors so far are 2x minus 3 times our result, x squared minus 25, but we're to use the result to factor completely this x squared minus 25. Of course, factors difference of perfect squares into x plus 5, x minus 5. Okay, so on 9 and 11, if you end up getting a remainder on this, in this section, we should not. So that's going to be a reminder to double check. I will tell you there's a good chance that your number 11 takes an extra step than my number 12 does here. We got that bonus 0, yours might not, so you can see where you're going to want to have sharp pencil, write fairly small. And 16 may press us as much as any of these. The ones that are going to take the most steps are going to be where the degree of this first degree is smaller by a bigger factor than to the fourth. So we're going to have we're going to have a few steps to go through here, not just a couple of steps as we're doing the long division. So here we're to long divide. So I've got 2x plus 1 is being divided, or excuse me, is going into 8x to the fourth. Now here's where we have to talk about holes in the polynomial. There's a missing x cubed, a missing x squared, and a missing x before we ever get to the 5. We have to include those. So here we go. So plus 0x cubes plus 0x squareds plus 0x's and minus 5. Okay, it's essential that we do that. And in fact, later on, when we're dividing by x cubed minus 1, we're going to have to write that as x cubed plus 0x squared plus 0x minus 1. So 2x times what gets us to 8x to the fourth? 4x cubed. Oops, I should put that over here since it's cubed. 4x cubed. And 4x cubed times 2x squared is 8x to the fourth plus 4x to the third times 1, 4x to the third, but we are subtracting opposite. We get 0 as we should here, and 0 minus 4, we get minus 4x cubed. Bring down the plus 0x squared and continue. 2x times what is minus 4x cubed minus 2x squared. And that gives me minus 4x cubed and minus 2x squared. And there it is. Every single time I do it, but opposite, we are subtracting. 4x cubes cancel. I get 2x squared plus 0x. 2x squared goes into, or 2x goes into 2x squared x times, so plus x. X times 2x, 2x squared, x times 1 plus 1x, but we are subtracting, and I get minus x minus 5, and 2x goes into negative x. You might say, well, it doesn't go into it. So ask yourself, 2x times what equals negative x? That would be minus 1/2. Minus 1/2 times 2x is minus x. Minus 1/2 times 1 is minus 1/2, but we are subtracting, and I get 0. Negative 5 plus 1/2 is negative 4.5. And so our solution, we're not supposed to factor this. It didn't have to divide out evenly here. We're just supposed to do the long division. So our solution is 4x cubed minus 2x squared plus x minus 1/2. And normally here, in old school, we might say, well, with the remainder of this. But if I go back to this page, as we grow out of the remainder, we would say our answer here is 7 plus the 2. The remainder of 2 still needs to be divided by 5. 7 2/5 is what we would end up with if we did that division. So we're going to do the same thing here. So we have this minus 4.5 that still needs to be divided by the 2x plus 1. Now I suspect the back of the book probably multiplies this by 2 on 2, and we get, told you we'd test your small writing abilities, 4x cubed minus 2x squared plus x minus 1/2. If I multiply top and bottom by 2, I get minus 9 on 4x plus 2. Okay, and that actually is the longest. We have more steps in this one than when we do in the other, because the degree difference here is 3. The degree difference here to get from second to the fourth is just 2, and the degree difference here to get from third to 5 is just 2. So if we can get that one fit in there, we're in pretty good shape. Here we have a difference of 2, a difference of just 1, and a difference of just 1. So you're going to have a little bit more room for 15, 17, and 19 than we had for 16. Okay, 18, the order is important. We're going to divide by x squared minus 2x plus 3. What are we dividing? Got some holes here. I don't have any x cubes. I don't have any x's. So we've got x to the fourth plus 0x cubed plus 3x squared plus 0x's plus 1. Okay. We ask ourselves x squared times what is x to the fourth? X squared. So I put that in my x squared column. Distributing to all of these terms, I get x to the fourth. I get minus 2x cubed. I get plus 3x squared. But we are subtracting opposite, opposite, opposite. Cancels it better. Here we get 2x cubed. Cancels plus 0x squared. Bring down plus 0x. Ask yourself, x squared times what is 2x cubed? 2x. Distribute 2x cubed minus 4x squared plus 6x. Here it is, but we are subtracting, so opposite, opposite, opposite. Cancels it better. 4x squared minus 6x, bring down the plus 1. Ask yourself, x squared times what's 4x squared? Plus 4. Distribute. 4x squared, 4 times minus 2x, minus 8x, 4 times 3, plus 12, but we are subtracting opposite, opposite, opposite. 0, 2x, minus 11. At x squared, we can't get it into 2x. So that's our remainder, which still needs to be divided by this. So our solution is x squared plus 2x plus 4 plus the 2x minus 11 that has yet to be divided by x squared minus 2x plus 3. Alright, there we go. 20. Let's see. A little help here. There we go. 20. I've got holes here what I'm dividing by. I'm dividing by x cubed minus 1. I need to go x cubed plus 0x squared plus 0x's minus 1 into, lots of holes here, x to the fifth plus 0x to the fourth plus 0x cubed plus 0x squared plus no x's, and finally plus a 7. Have to fill in those holes to do this. Okay, x cubed goes into x to the fifth x squared times, and we get distributing to each term. We get x to the fifth plus 0x to the fourth plus 0x cubes and a minus x squared. But we are subtracting opposite, 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 opposite. So the x to the fifths cancel. I have no x to the fourths. I have no x cubes. And I'm already down to, take a look at this, I'm already down to x squared. That was a couple bonus zeros there. And I'm going to have 4 terms if I write all this out, so I can bring all these down, 0x plus 7, but x cubed doesn't even go into x squared. So this is like 0x's, this is it. We're just at x squared. I can't divide x cubed into x squared, so plus the remainder, x squared plus 7 on x cubed minus 1. And so that was kind of fortuitous there. And so I think spacing wise you should be in pretty good shape on these. When you get to 17, be careful. We of course have to write this as 10x cubed minus 2x squared plus 5x minus 1. We have to fill in the holes. We got a couple holes here. We have 0x squareds, we have 0x's. We've got a couple holes here. We have 0x squared, 0x's, and here we have 0x's. We have to have those holes filled in. So there you go. That's a little bit longer page. Of course, we talked about the notes somewhat. Write small. Let me know if I can help.